Welcome to the course on resource capacity. After completing this topic, you will be able to define, analyze, and manage resource capacity. Please note that a prerequisite for this topic is familiarity with the course topic's production concept and resource. A significant part of the production process involves the consumption of resources. We can define available capacity, consume it in production, and manage resource capacity availability. This functionality allows us to plan and monitor the capacity of the resources, to avoid bottlenecks and optimize production planning. In this example, we look at the company OC Wood Trend, which produces custom wooden doors and windows based on customer specifications. They use a make-to-order production process in which deadlines are derived from the delivery date of their customers' orders. Managing resources and their capacities is crucial for OC Wood Trend to assure timely deliveries to their customers. They need to identify whether production can go ahead as planned or whether manual scheduling adjustments need to be made to meet deadlines. To manage the capacity of a resource, you need to generate the available capacity. You do this in 2 steps. In step 1, you define a weekly plan, where you set the expected capacity of the resource for each day of the week. In step 2, you generate the capacity for a whole period, such as a quarter, by copying the weekly plan you defined in step 1 to the whole period. Alternatively, you can set the capacity manually for each day in the period. There are 2 types of daily capacities that should be defined: internal and single-run capacities. A single-run capacity assumes only one production order can be produced using a certain resource in a certain period. With internal capacity, this kind of limitation is not taken into account. The result of these steps is an available capacity, internal and single-run, that allows you to manage and allocate capacities in the production process. You can plan capacities for your resources on the Planning Data tab of each Resource Master Data record. These capacities are defined on a daily basis. 4 factors are available and you can set them for each day of the week. These factors allow easier definition of capacities of a specific resource. A factor can be used, for example, to represent the number of working hours in one shift, the number of shifts in the specific day, or the number of machines, resources. Note there are 2 types of capacities, internal and single-run. The internal capacity is a simple calculation of the factor columns multiplied with each other. In our case, 32 cycles a day is multiplied by 2 available machines, resulting in 64 cycles as the internal capacity. The single-run capacity, however, only takes factor columns that are marked as relevant for single-run capacity into account. In our example, only factor 1 is relevant and therefore each day has only 32 cycles in the single-run capacity. Note that you can also enter a value in the daily capacity and single-run capacity columns directly. The next step is to generate daily internal and single-run capacities for a specific time period. This step is done on the Set Daily Internal Capacities window in the Resources menu, or from the Context menu of the Resource Master Data. Here you can generate capacity values by either copying the standard daily capacities defined in the Resource Master Data or entering the capacity manually. You can also use this window to copy single-run capacities to the internal capacities and vice versa. The generated internal and single-run capacities can be then viewed in the Resource Capacity window and also in the Capacity Data tab on the Resource Master Data. The Resource Capacity window provides a complete capacity overview of selected resources within a selected time period. A user can select different views, such as internal, available, and single-run. Then, you can see the relevant amount of capacity on a specific calendar day for the specified warehouse. The meaning of the different views is discussed further on the next slide. Note that the resource capacity can be defined for multiple warehouses. This can be relevant when warehouses are set up as production areas. Each warehouse can then have its own capacity and capacity allocations. The relevant defaults can be defined in the General Settings Resources tab. The capacity of a specific resource can be also viewed in the Capacity Data tab on the Resource Master Data. In this case, the capacities are summarized for the capacity period selected at the top of this tab. The capacities are displayed as internal, committed, consumed, and available. Internal capacity is the full resource capacity in the selected time period. Committed capacity is the capacity allocated to a specific production order in the selected time period, but was not issued to production yet, open quantity. Consumed capacity is the capacity that was consumed in the selected time period, for example, issued for production in the selected time period. Available capacity equals internal committed consumed. Note that the committed resource capacity that is related to a specific production order, is allocated according to the date, start date or end date, in the row of that production order. There are different resource allocation methods are available. This topic will be discussed further on the next slides. Let us examine the numbers. We defined an internal capacity of 1,536 cycles for the defined period. 24 cycles of the internal capacity are committed to a production order, 6 cycles were already released in an issue for production, and 1,506 cycles are left to use if needed. In the resource training, we learned about connecting a resource to an item, to buy or sell resources. Some of the purchasing documents also generate capacity that is accumulated in another column, called ordered. To learn more about the ordered capacity, refer to the How to Guide, How to Work with Resources and Production in SAP Business 19.3. We saw that the resource capacity window has a column for each day in the specified range. In each day column, we can see the internal /committed /consumed /available quantities. The system allocates the committed quantity, derived from production orders, according to the start or end date of the production order rows. There are 4 resource allocation methods. On start date, the entire row quantity is allocated to the start date of the row. On end date, the entire row quantity is allocated to the end date of the row. Start date forward, the committed quantity is allocated according to the available single run capacity for each day. The system checks each day, starting from the start date, or the system date in case the start date is earlier, whether or not the capacity can fulfill the committed quantity. If there is not enough quantity on that day, the system checks available capacity quantity on the next day, until the system finishes allocating the entire committed quantity. If the system reaches the end date and there is still quantity to allocate, then the system allocates the remaining balance quantity to the start date. End date backwards, this method is similar to the previous one, but instead of allocating from the start date forward, allocation is performed starting from the end date backwards. For production orders with no routing, we can set the default resource allocation method for each resource, as shown in the image. However, we can also change the allocation method in each row of the production order. On the next slide, we will examine an example of allocation according to the different methods. Let us look at the example shown here, to better understand the different methods. We have a production order with a resource row quantity of 10. The start date in the row is March 1st. The end date in the row is March 4th. Let us see the possible available outcomes with each method. When using the onStartDate method, the entire quantity of 10 is drawn from the start date, March 1st, which results in a negative available quantity of -4. Nothing happens on the following days. When using the onEndDate method, the entire quantity is drawn from the end date, March 4th, which results in a negative quantity of -2 on March 4th. When using the StartDate forward method, the available quantity of 6 is fully used, then, going one day forward, to March 2nd, the entire available quantity of 3 is drawn as well. Since an additional quantity of 1 is still needed, it is drawn from March 3rd, leaving a quantity of 1 remaining. Nothing happens to the quantity from March 4th. When using the end date backwards, the available quantity of 8 is fully drawn from the end date, March 4th. Then, going backwards to March 3rd, the entire quantity of 2 is also drawn, to complete the quantity of 10 needed for this resource. The start date forward method can be relevant when production is being made to raise inventory levels and when the end date is not critical. It is more important that the inventory be produced as soon as possible. The end date backwards method can be relevant when production is being made for specific customer demand with a specific due date. Assuming we want to minimize the inventory held in our warehouses, we want to produce on a just-in-time basis, so that a customer order demanded at a specific date will be supplied on that date and not sooner. The resource capacity window also provides a cumulative capacity view. In this view, all the capacity quantities are accumulated daily. Each day shows an accumulation from the preceding days. This view can be helpful for spotting when a resource capacity is overcommit. To switch to the cumulative capacity view, select the Show Cumulative Capacity from Today checkbox. In the upper image, we see the resource capacity window. Notice that on May 3rd, there is a negative available quantity of -26. But is that a true overload? The production manager can easily bring forward the production to the day before. The cumulative view, as shown in the lower image, can more clearly indicate a true resource overload. In our case, no negative available quantity appears, since the quantity is accumulated from today forward. A negative available quantity, however, would indicate that the total available quantity up to that date is negative and that the total commitment is higher than the total internal capacity. In this case, a manual change of production order dates can help to avoid negative available quantities. Here are some key points to take away from this session. The resource capacity feature visualizes available capacity to avoid bottlenecks and optimize production plan. There are 4 capacity views: internal, committed, consumed, and available. A daily standard capacity can be defined in the Planning Data tab of the Resource Master Data. An internal capacity can be generated according to the planned daily capacity. Resource capacity can be allocated on the start date of the production order row, end date, from the start date forward, or from the end date backwards. The cumulative view, in the resource capacity window, can be helpful in spotting when a machine's capacity is overcommit. You have completed the topic for sales order to cash. Thank you for your time.